Okay, well, trying to do this integral, it's a little hard to get a handle on it until you've got a picture of the function. So let's get a picture of the f of t minus lambda function. First of all, if you regard this as a function of t, which you don't really want to do since you're integrating with respect to lambda, but the easiest thing to understand is just how this horizontally shifts. F of t minus lambda shifts f of t horizontally by lambda units, right? So that would be f of t minus lambda. Okay, well, this is good stuff, but it's not very important, okay? Except as a step in understanding what happens f of t minus lambda is a function of lambda, because that's our integration constant, our integration variable, okay? Lambda is our integration variable. So as a function of lambda, f of negative lambda does what? Well, if you do a function of the negative value of the variable, it flips the function across the t-axis, or the lambda axis in this case, okay? The vertical axis. So this function here flips here. And we could write this function. I didn't write it down because we're just getting a picture. But now that we have the picture, let's just notice that f of negative lambda equals negative lambda for negative 1 less than or equal to t than lambda less than or equal to 0 and 0 otherwise. And we get that just by replacing t with negative lambda. So if negative lambda is between 0 and 1, lambda is between negative 1 and 0. Okay? So we could write this out. Might or might not be useful, but we want to have the ability to write this function out. Okay? Then f of t minus lambda, which is what we're integrating, is f of negative quantity lambda minus t. So that's like f of negative lambda shifted t units in the horizontal direction. Okay? Graph of f of negative lambda shifts horizontally t units. There it is. Okay? And that's equal to lambda minus t for t from, or for lambda from t minus 1 to t. So just to clarify that, or I'm not sure it clarifies, just to give us the ability to write that. So this equals 1 for t minus 1, well, lambda between t minus 1 and t, and it's not 1, it's, I didn't leave myself enough room to write what I should have. And it's not equal to t minus lambda, it's, yeah, well, it has to be, and 0 otherwise. Yeah, that's right. Okay?
I got a question, Mr. Smith.
Yeah.
Okay, so I followed you up to the point where f of t minus lambda is, and that's f of negative of lambda minus t. Wouldn't that make the t a positive, so that would shift to the left instead of the right?
No, you're replacing lambda with lambda minus t, and you're shifting the f of negative lambda function.
Okay.
So in the f of negative lambda function, lambda is being replaced by lambda minus t.
Okay.
When you replace the variable by the variable minus h, it shifts at h units.
Okay.
Okay? I understand what you're saying, because it's real easy to
Right, okay. I just wanted to make sure I was not messed up.
real easy to do this.
Right.
Okay? And maybe I screwed it up. We'll see.
Oh no, I just wanted to follow what was
I'm
happening.
reasonably sure of this. Okay, so, check me out. We'll check it out with the example in the book, which is totally analogous. Okay? And I think the picture in your book ends up looking pretty much analogous to this. okay? And really then, between t equals 5 and 6, well, t, which is where this thing dives down to 0, is between 5 and 6, right? So geometrically, or graphically, when you're integrating it, you're finding just this area, right? But that integral then is the integral of t minus lambda from 5 to t. Lambda equals 5 to lambda equals t. Okay? And that'll reconcile with this picture. So let's write out that integral and work it. And we'll get set up for that here.